All right, so as I mentioned in the last video, some of the differential equations will be hard to solve, okay, or they're very complicated. But how do I find out the solution? So in that case, there are certain techniques we use. So one of the technique is slope field or direction field. Drawing the slope field and direction field, that will tell you how would the solution look like, okay. And another technique is the Euler's method, which is a numerical method. We will discuss that later. First of all, let us talk about the slope or direction field, okay, which is still section 6.1 from the book. So slope and direction field is basically a very simple graph. What we do is we plug in different values of x and y and then find out y prime, which is the slope. And we draw a tiny line segment to represent that slope. Okay, guys? So let us do example right away. Okay? So what I want to do here is I want to make a table and pick a different points for x and y. Okay? And then x, y, and y prime. So let's say x, y, y prime. Okay? And then let me make a graph right here. Big graph there. Okay, guys? So, and then on the graph, just mark 1, 2, 3, 4, 5 like that. 1, 2, 3, 4, 5. 1, 2, 3. This is negative side, right? And there is -1, again -2, -3, -4, -5, and so on. Okay, guys? So this is x-axis, this is y-axis. What I'm going to do is I am going to take different values of x and y. Okay, so let's first pick 0, 0. X is 0, y is 0. What will be y prime? Plug in here. So y prime is 0. So there is no line segment because the slope is 0, right? What is the formula for slope? M equals to slope, right? It is rise over run, which is same as y prime, right? Okay, so let us pick 1, 0. 1, 0 is, this point is 1, 0, right? When you do 1, 0, what will be y prime? Y prime will be 2 times 1 is 2 plus 0 is 2. So the slope is 2. So slope is 2 means 2 over 1. Rise is 2, run is 1, right? Rise is 2. From 1, 0 is that point, right? That point is 1, 0. Rise is to 1, 2, and then run is 1. Run is 1. So draw that line. That's what we got, line segment, right? Let me put 0, 1. If y is x is 0 and y is 1, you will get what? You will get 1, right? Because 2 times 0 plus 1 is 1. So at 0, 1, it is 1, meaning 1 unit. So rise over run will be like this, right? Rise 1, run 1. It is like that. You see that? Similarly, let us put a point at 0, -1. 0, -1. How would that look like? 2 times 0 plus -1, right? On here, 2 times 0 plus -1 is -1. So rise is -1 from here. Rise is -1. It goes down and run is 1. So it goes like that, right? So it will look like that. You see that? So this is what it looks like. Okay, and similarly, let us pick at 0, -1, 0. So -1, 0. What will be the slope at that time? 2 times -1. 2 times -1 plus 0. So that is -2. -2 is same as rise over run is -2, -1, -2, and then 1. So it will look like that. Okay, and if you continue that, okay, which is also given in page number 409 of the book, okay, if you continue that, your line will look like, you know what, your lines will look like that. Your line segment will look like that. Okay, your line segment will look like that, and then on this side it will look like that. All these are line segment. Okay, all these are line segment and look like that, like this. Okay, guys, and then like this. So if you keep drawing at each of those points. Now if you want to draw a line segment that goes from 1, 1, where is 1, 1? That's the 1, 1, right? That is the line segment that passed through 1, 1. Okay, guys, if you do that, how would that look like? it will go like this, and then it looks like this there, right? It is kind of parabola. You see that? This is kind of parabola. So this is the solution that goes through 1 1. It is similar to that. You can guess, but you see that when you see that goes through 1 1, this is the line segment that goes to that's the solution curve. We call solution curve. That's the solution curve that goes through 1 1. If you draw, like, you just capture the trend, how that line segment are going. Okay, now, and also when x tends to infinity, if you go to the extreme right side, how that solution look like? That solution look like it is going to infinity, right? So when x tends to infinity, then y is the solution curve, that black curve goes to infinity. Similarly, when x tends to negative infinity, on the left side, it is also going up, right? So y also tends to infinity. Okay, guys? So this is what we get when we draw the direction field of y prime equals to x plus y. You can basically see how does the solution curve look like. If you try to solve this, if you try to integrate this, it is very hard to solve now because you haven't learned any techniques of solving the differential equation. It is hard to solve this equation, okay? Because we don't, you are not aware of any techniques that help to solve this one, to integrate this one, okay? So, but this method tells you how would the solution look like basically, okay, guys? Because when the slope is positive, then the curve look like the actual solution will be increasing. When the slope is negative, then the actual solution will be decreasing, right? So for the negative one, the solution is going like that. For the positive one, it is going up. And for the 0, okay, at 0 0 it is 0, okay, and then there will be other points that you will see that they are 0. At 0 it will be just a vertical segment, and so on. Okay, guys? All right, this is how you do it. So for any equation, you just pick different values, and then you may have question like what point of x, what values of x and y should I pick? And you can pick any values. But if you pick close values of x and y, 0 0 1 0 0 1, and around that, and you will get the clear picture how would the solution look like. Okay. All right, guys, so we just learned about how do we draw the direction field manually by hand, right? But there are some good people online that one of the professor has made an app, free app available online, maybe for his students or for anybody, because I was able to access that, right? So what I'm going to do is I'm going to share that link, okay? That link name is slope and direction field drawing, okay? So the website is homepages.bluffton.edu, and then slash, and then that wiggle sign, and then nested slash apps slash slopefields.html. So he made a free app. He made an app, and this is available free to anybody to use. Okay, so there are several options here. So what you can do here is, so there is one ODE. If there is one ODE, so we were working on 2x, and then plus y, right? You type that differential equation, and you see that is the direction fields or the slope field, okay? And if you want to draw a particular solution that pass through a given point, let's say, let me find out how does the solution look like, or a particular solution look like if that pass through 0 0. If I click at 0 0, it gives you how the solution look like, okay? And if you want to do a solution at, let's say, at 1 0, almost 1 0, if I click it here, that is the solution look like that pass through 1 0. Okay, so you can draw any, for example, 1 and then -1 somewhere here. If you click it here, and that is the solution that passed through 1 and -1. Okay, so you can basically figure out how does you can basically approximate how does the solution look like on a solution of a differential equation look like, just in case if you don't know how to solve it manually. Okay, guys. All right, so this is a free app you can always use to estimate the solution or a particular solution or the direction field of a differential equation. All right, So the next thing I want to do is I want to do the numerical solution of a differential equation. Okay, so to find the numerical solution is basically, this is an approximation, this is not an exact solution. What we do is we estimate the derivative by the definition and then pick a certain step size. Okay, so what is the definition of the derivative? So the definition of the derivative is dy over dx equals to f of x plus delta x minus fx over delta x, limit delta x tends to 0, right? When you take the limit, so if it is limit delta x tends to 0, f of x plus delta x minus fx over delta x. That is the definition of the derivative, right? So we will find out, we will estimate the derivative at each point, okay, and then we will estimate the solution that way. Okay, so what it is doing here is, for example, suppose I want to find the solution. So you will be given like at x y at 0 is equals y at x 0 is equals to y 0. This will be given to you. Y at x 0 is y 0. Okay, so at x 0 the height of the solution is y 0, that is x 0 y 0 is the point. Okay, now what we try to do is we try to estimate what will be the height of the function, what will be the height of the solution at x1. So what we do is we draw a tangent line at x0 y0 and we use the height of that tangent line at x1 to find out the height, to approximate the height y1. Okay, so for y1 is the height at x1. To approximate the y1, what we do is we draw a tangent line at x0 y0 and use the same tangent line's height at x1 to approximate the height y1. Similarly for x2, to find out y2, height of the y2, what we do, we draw a tangent line at x1 y1 and find out that. But how do we do the tangent line? Do you remember the linear approximation in calculus 1? That's what we are doing. Okay, so first of all we divide into several sub-intervals, x0, x1, x2, like that. So the width of each of the segment is h. So what do you get? x1 is x0 plus h, x2 is x1 plus h, which is x0 plus 2h, because x1 is x0 plus h, and continue that way. Okay, now to find out the height y1, to find out y1 equals to what? To find out y1, because y0 is given, y0 is y0, right? That's given. At x0 height is given, will be given to you, y0. Now to find out the height at y1, what we do is we use the derivative. So what is the derivative? Derivative, because you see that the derivative at that point is rise over run, right? So that is y1 minus y0 is that over x1 minus x0, right? x1 minus x0 is h. That is h, right? y1 minus y0 over h. That's how we denoted. We approximate the derivative by the slope. That's what we're doing, right? And at the right hand side, what is the height at x0 y0 is so we are basically replacing at x0 y0, so xy by x0 y0. So the right hand side I'm keeping the same function, but I'm taking just at xy, I'm using at x0 y0, that point. Okay, so I'm trying to find out the slope at x0 y0 or derivative at x0 y0. So on the left side I found the derivative, dy over dx is rise over run. Okay, that is y1 minus y0 over x1 minus x0, which is h. On the right hand side I'm picking the same function but at the point x0 y0. If you solve this, you will get y1 equals to, multiply by h, you get y0, you move this to the right side, plus h times f of x0 y0. Okay, now similarly do at the point, to find out x2, you find out rise is y2 minus y1, right? And run is again h. So y2 minus y1 over h equals to f of x1 y1. You do that and then you solve for y2. Okay, this is what you get. If you continue that way, you get y sub n plus 1 is equals to y1n plus h f of x and yn. This formula is called the Euler's method or Euler's formula for the differential equation. Okay, and for n equals to 0, you will get y1 equals to. For n equals to 1, you will get y2 equals to. For n equals to 2, you will get y3 equals to, and so on. So you will get the formula like that. Okay, So now how do I use this formula to find out the solution of the dy over dx? So we will use formula to find out x0. We will find out x0, y0 will be given to you. Then after we use that given thing, we use x0, y0 to find out x1, y1. X1 will be that point. We will find out that x1. But to find out y1, we use that formula for x1, y1. So you find out x1, y1, then find out x2, y2, and so on, and continue that way. Then we will join all the points. That's our idea. Okay, guys. So let us see one example. Then you will understand that. So example is, this is question number 73 from your book. Okay, 6.1. So it says approximate the solution of y prime equals to x plus y, and then y at 0 is 2. So y at 0 is x0 is given. Okay, so x0 is 0. So x0 is 0, and then y0 is equals to 2. H, that width is given at 0.1. Okay, so I made a table here. So I equals to 0, 1, 2, 3, 4 like that. Continue that way. Xi will be x0, x1, x2, x3, x4 like that. Yi and f of xi. What is f of xi? This is f of xy, right? So f of xi, yi will be xi plus yi. That's what I put that function here. Okay. X0, when I is 0, xi will be x0. What is the value of x0? Is 0. Y0, yi will be y0, which is 2. What is f of x0, y0? Why do I need to find out that? We don't need to find out that to plug in x0, y0, but for x1, y1, you see that to approximate y1, we need f x0, y0. That's why I find out that f of x0, y0 will be x0 plus y0, which is x0 is 0 plus 2 is 2. So we found f of x0, y0, which will be used to find out y1. Okay, so what is x1? X1 is x0 plus h. 0 plus h is 0.1, so it will be 0.1, right? So now y1 will be what? What is the formula for y1? You plug in n equals to 0, or you can just use that formula. That is the formula for y1. y0 plus h times f of x0, y0. What is your y0? y0 is 2 plus h is 0.1 times f of x0, y0 is 2. If you do that, you will get 2.2. Okay, so another point is, first point was 0, 2. Second point is 0.1, 2.2. 0.1, 2.2. We got that. Now I want to find out f of x1, y1, because to find out y2, I will need that f of x1, y1. That's why. So f of x1, y1 will be x1 plus y1, because f of xy is that, which is x1 is 0.1 and y1 is 2.2. So 0.1 plus 2.2 will become 2.3. That's what we got. And then I noted that. And then let's find out at x2, at when I equals 2, you will get x2 is 0.2. Okay, because x2 is what? X1 plus h. X1 is 0.1 plus h will be 0.2. Now to find out y2, the formula is y1 plus h times f of x1, y1. y1 is 2.2 plus 0.1 is h, plus f of x1, y1 is 2.3. I did that, and I will get 2.43. Okay, so at 0.2, y2 will be 2.43, and so on. Continue that way. Okay, after you find out all the order pairs of xi, yi, you start to plot. At 0, it is 2, 0, 2. At 0.1, it is 2.2. That is another point. At 0.2, it is 2.43. At 0.3, 2.69. 0.4, 2.99, and so on. And then you join that. Okay, after you join that, you will get the equation of the solution, or the graph of the solution. So this is how we find out the solution curve using the Euler's method. And in your differential equation class, that is the next class you will take after calculus 2, okay, you will see more numerical method. This is the Euler method, which is very, very basic. Okay, and in the differential equation class, you will see more other numerical method too. Okay guys, so this is how you solve the differential equation using numerical method. All right, thank you.